My name is Ken Libbrecht, and I'm a physicist at Caltech, and I study crystal growth. It gets pretty involved, but basically, I'm growing crystals and observing how they grow and trying to understand the physics of that. I sort of soon decided ice was a really good case study. One reason is it's very cheap and very easy to grow. So the first thing I'm doing is the needle has a bunch of ice on it, and it's too much. So I've got this little thing in there that is hanging from a thread, and I gently tap that very fine needle to get a lot of the ice off. Then it turns out the growth of needles needs a little bit of chemical stimulant. So this is mostly vinegar vapor, and I put just the tiniest amount of vinegar vapor in the chamber, just a smidgen. Then I turn on the high voltage and I watch and wait, and so now needles are growing, these very, very thin ice needles, and that's big enough. So I open these shutters and I pull this over gently so as not to break the needles, and if it all works well, then I get a bunch of needles on the screen, which is what I have there. I can rotate it around a little bit and focus on it, and that's a pretty good one. The lore that no two snowflakes are exactly alike, and to some degree that's true. The crystals are quite complicated in shape, and so the number of possible ways to make a snowflake is very, very large, and so the odds of seeing two identical snowflakes is very rare. On the other hand, we grow crystals in the lab, and we specialize in growing little tiny hexagonal crystals with as little structure as possible. And when you grow very simple crystals like that, they all look about the same. So it kind of depends on what you mean by a snowflake.